something ended up bugging me after I finished recording the previous episode, and that was I was wondering, isn't there a way to implement our binary digit parsing algorithm in a different manner and that is still functional but resembles the traditional approach a little bit more so that it's easier to reason about? And I think there is one, and I'd like to share it with you. And that is the recursive way that we've been using, where we do this thing where we call first on a collection and rest on a collection and recur over the rest. So over time, we have successively fewer items to iterate over. I think there's a way that we can do the same thing here. So let's call this approach to decimal recursive, if I can spell it right. And it's also going to take a base and a collection of digits. But if we're going to do this recursively, we also have to keep track of a couple of additional items. The first one is the result of what we've calculated so far. And that's going to start out at 0 because we're adding stuff together. And we're also going to have to keep track of the exponent that we're currently at, because remember, this changes based on the position in the collection of binary digits. If we're at the first one, we have exponent 0, or I should say the last one really in order. If we're at the second to last one, you have exponent 1 and so forth. So the exponent we start with is the leftmost one right here. And so what the exponent is there, since we read it from right to left, depends on the length of this collection, on the number of items in that collection. If the number of items is 4, the highest exponent is 3, and then that's the one we're going to start with. And so if the number of elements in this collection is n, then the highest exponent and the exponent that we start with is n minus 1. So the exponent that we start with is the count of the digits minus 1. Okay, and then we do what we've been doing this whole time, which is if there are no digits left to iterate over, well then we simply return the result that we've computed so far. Otherwise, let's take the first digit and calculate the next result. And that's going to be taking the previous result plus our current digit times the base to the power of the current exponent. And so this line right here is now very similar to what we did in our traditional implementation. Virtually the same. And then what do we return? Well, we return a call to the same function again. The base isn't going to change, but the digits we have to reduce now to only the rest. I don't mean reduce as in calling the reduce function. I mean reduce as in shrinking the collection. Otherwise, we'd be iterating forever, or recurring forever, I should say. And we pass in the new result, and we decrement the exponent. And that's it. I think this should work. Let's run it. So let's say our base is 2, and we give it the same number that we gave it before. And there you go. It's number 11. If we give it a different number, I hope that's right. And if we give it base 10, this works also. There's one more thing we could do, and that is instead of saying new result equals this here, we could instead say return result plus this. So we could also do this here. And I think that would work the same. but there's a problem with this, and that is, so if you run it this way, you're not really doing what's called tail recursion anymore. Tail recursion means that the call to the function is the very last thing you're doing. But that's not really the case anymore, because the last thing you're doing here is performing addition. And the trouble with that is, if it's not tail recursion anymore, then some browsers that support a certain optimization can't support that optimization anymore. And that, I forget what that optimization is called, but Clojure does this by default. If you're using tail recursion, they actually pop when you're done with that function, before it invokes the function again, it pops it off the stack. So that way you can never run into a Stack Overflow. If you do it like this, it couldn't do that. Some browsers, I think, are now either planning to, or they already are supporting that. So if your digits collection gets really large and you have to parse a really large number, you could technically run into a Stack Overflow, although in this particular use case, it'd have to be a really big number. But in general, I think it's good to know that that optimization exists, and it's good practice to stick with tail recursion. So here you have it. This is, I think, perhaps a better implementation than the previous one. It sort of depends on your preference. And I think it's always a good idea to try and implement several different solutions to the same problem. Because in the words of the famous philosopher Karl Popper, he said, whenever a theory appears to you as the only possible one, take that as a sign that you have neither understood the theory nor the problem which it was intended to solve. And I think that applies to programming as well. Think of several different solutions to the same problem, because it allows you to understand the problem better, and then at the end you can pick which solution you like best.